I'm Alan Perrin,
And I'm Dylan Greenfield.
and together we created the oscillating horizontal engine.
The main assembly is made up of 4 subassemblies and 1 part. The subassemblies include SA101, SA102, SA103, and SA104, as seen later in the slides. The one part that was not included in any subassembly was the wood base. Overall, the project as a whole went together smoothly with very few problems.
The way we divided up our parts were by complexity, not by the number of parts. So Dylan created 10 parts and Alan, created 8 parts. We worked mostly together on Saturdays, either to decide what to do on the upcoming week or to work together as a team. When we both finished our parts, we compiled them to one folder and then assembled all of the parts into their specific assemblies as a team, not as an individual, because all of the parts were not corresponding to one specific subassembly. They were all kind of mixed throughout several subassemblies. On February 16th, all our assemblies were completed and we were ready to start our main assembly.
Me and Alan divided up the parts in the sense of how difficult each part was to do. So overall we had 3 hard parts, 8 medium parts, and 7 easy parts. While Alan completed the 2 most complex parts, I took 5 medium parts and 3 easy parts to make it even. So in all I took 10 parts and Alan made 8 parts.
Subassembly 101 was made up of 4 parts: base frame 01, crankshaft bearing bush 02, cylinder pivot bush 03, inlet outlet pipe 16. All constraints for this assembly were rather simple. They were either coincidences or offsets of 0, which made this assembly quick and easy. Base frame 01 sits on the wood block and is the base that the rest of the assembly is set on, so that is what made this part an important assembly. But as far as assembling goes, it was quick, easy, and there were no problems in doing it. Base frame 101 was one of our more complex parts. Base frame 101 is used in subassembly SA101, and the image to the right was the image that we were provided on our drawing sheet. It had some missing dimensions, but the cool thing about this part was the unique ways it used geometry to dimension itself. So right here, you see the 90 degrees and this dimension of 21. It goes through the center line of these 2 holes. So in order to figure out the alignment of these 2 holes and then the opposing 2 holes, you actually have to use this fun geometry, which I dimensioned in a cleaner way, but I found this part to be unique because it took some trig to figure out how you were going to get some of these lines to line up and to account for all the dimensions. And when I did this, I actually couldn't get that radius of 11 to line up with this construction line. So I had to go through and make some modifications to the dimensions that I was given, but in the end, in the assembly, it works out better the way that we assumed things to be rather than the way that we were provided.
Subassembly 102 consisted of only 3 parts: crankshaft 04, crank disc 05, and flywheel 06. We ran into a problem while creating this assembly, which was the fact that there was not an offset specified between flywheel 06 and crankshaft 04. Since flywheel 06 is only held on with a set screw and there was no call out stating where the flywheel 06 sat on the crankshaft 04, we decided to wait until the full assembly was complete to determine a fixed distance for the flywheel on subassembly 102. Also, I was the one who created the part crank disc 05. When we were trying to assemble this part into subassembly 102, we were having troubles for a while until we figured out that I had missed a hole that attached the cross section of crankshaft 04 to crank disc 05. Also, we had to make assumptions and had difficulties in making the part flywheel 06, which will be covered in the next slide. This is a section view of flywheel 06 used in subassembly 102. The main issue I had in creating this part was inserting a 30-degree angle hole for a set screw to go in and keep flywheel 06 stable as it spins. To solve this issue, I actually had to confer with Alan on how he might do it. We ended up making a couple of different planes to get the right plane in the right spot and at a 30-degree angle. On this part, there was not a chamfered edge, so I assumed what looked best and moved on, being that I did not think it would affect the function of the flywheel.
Subassembly 103 was made up of 7 components: cylinder 07, cylinder front lid 08, cylinder rear lid 09, cylinder pivot shaft 10, pivot shaft spring 11, piston rod gland 12, and cylinder logging 18. The two ovals represented on the screen, you can kind of see that the cylinder logging and the two lids kind of overlap. This is because the cylinder logging would be made of sheet metal, or in the sheet metal workbench. So as you were putting the logging on, it would clamp and then deform itself to tightly fit over the two lids, but we don't know how to deform that in CATIA and in the part design that we used. So here you can see that they overlap in space, but logically that's impossible. So we had to live with that as an error in our design. The spring was not included in the assembly, but we decided to put it in subassembly 103 just to make it so that there was less parts in the main assembly. The spring would be compressed up against this nut on the side, and it would be pressed up between the nut and the base frame 01, which you'll see later in the main assembly. But what we did is just constrain it so that there's a contact point between the spring and the nut, and then the distance between the base frame and the spring slightly overlaps, but it's to a point or a tolerance that's small enough that we were okay leaving it there. The nuts and bolts were imported right from the CATIA library, and they were just of size to fit the holes that we were given.
Subassembly 104 has 3 components: piston rod 13, piston 14, and piston rod big end 15. When creating the piston, I did not realize that it was actually a subassembly of its own. So instead of delaying our schedule, we decided to create the piston and O-ring as one single part. I first created the piston by using the sketch and revolving it around a central axis. I then later created the O-ring and repeated the same process. The piston head was also supposed to be a mixture of material including cast iron, bronze, and graphite. Me or Alan could not figure out a way to do this in CATIA, so we made it bronze to match a lot of the other parts on the engine. Subassembly 104 is what we could call the heart of this engine, because it is what compresses and expands the gas and essentially is where the energy is produced. The only part that was not associated with our 4 subassemblies is wood base 17. I had to assume a few things on this part, as some of the information I needed was missing from our drafting sheets. I assumed the diameter of the pilot holes you see to the right. I created these with a diameter of 1/2 the width of the screw that goes into these holes, and at depth of 15 millimeters. This is due to the fact that the screws need wood to grab to hold the base frame in place. I also assumed the thickness of this part, so again I chose what looked the best, as I did not feel that this would affect the function of our engine.
The assembly was comprised of 4 subassemblies as mentioned earlier. As you can see from the picture, there was very little constraining. There's only 5 components and they all went together fairly easily. The only issues we had were the cylinder logging not deforming its shape and the spring not being compressed between its 2 other surfaces. As you can see, it goes together very nice, and we were very satisfied with the end result.
Overall, the end result of our project was rewarding and satisfying to see. As a group, we stayed ahead of deadlines for the milestones. We came across some scheduling conflicts during the last week and did not finish in the time frame that we gave ourselves, but overall the teamwork and communication between us was very helpful in working through the time crunch. We'd also like to give a big thanks to Val, our team mascot, for always attending meetings and boosting team morale.